Section 2.5. Our objective today is I can apply definitions and theorems about perpendicular lines. So the definition of perpendicular lines is two lines that intersect to form right angles. Okay, so if I have line K and line L, they form angle 1, 2, 3, and 4. And the symbol we use for perpendicular, it kind of looks like an upside down T. Okay, so if line L is perpendicular to line K, then by the definition we know that angle 1, angle 2, angle 3, and angle 4 are right angles. Okay, so by definition, we know that they're right angles. And the definition of perpendicular lines is actually a biconditional because the conditional and its converse are both true. The conditional would be if two lines are perpendicular, then they form right angles. And its converse would be if two lines form right angles, then the lines are perpendicular. Okay, so we can write that as or we can say it as a biconditional if two lines are perpendicular if and only if they form right angles. Okay, then we have several theorems that apply to perpendicular lines. So the first theorem says if two lines are perpendicular, then they form congruent adjacent angles. Okay, so if these two lines are perpendicular to each other, okay, they form congruent adjacent angles. So we can say that angle 1 is congruent to angle 2 because the lines are perpendicular, and angle 1 and angle 2 are adjacent. We can say angle 2 is congruent to angle 3. We can say angle 3 is congruent to angle 4. And we can say angle 4 is congruent to angle 1. So because of this theorem, we can say all those angles are congruent because they are adjacent angles formed by perpendicular lines. Okay, so the converse is also true. Whoops. Okay, so this theorem says if two lines form congruent adjacent angles, then the lines are perpendicular. Okay, so what this is saying is, let's say we're told angle 1 is congruent to angle 2. Well, angle 1 are adjacent angles, okay, by definition of adjacent angles, and they are congruent. Therefore, we can say that line K is perpendicular to line L. That's what this theorem says, and it's just the converse of the first theorem. Okay, then the third theorem says if the exterior sides of two adjacent acute angles are perpendicular, then the angles are complementary. Okay, so here's the picture. Okay, so if ray AB is perpendicular to ray AC, then angle BAD plus angle DAC have to equal 90 degrees by definition of complementary angles. Right? So let's look at some examples that apply these theorems and definition. Okay, so example. All right, so I have two lines. Line WY and line ZX, which form angle 1, 2, 3, and 4. Okay, so 1. If line WY is perpendicular to line X or ZX, then angle 1, angle 2, angle 3, and angle 4 are right angles. What allows me to say that? Okay, the thing that allows me to say that is definition of perpendicular lines. Number 2, if measure of angle 1, if angle 1 is congruent to angle 4, then line WY must be perpendicular to line ZX. What allows me to come to that conclusion? By knowing that this angle is congruent to this angle. Well, it's the theorem that says if two lines form congruent adjacent angles, then the lines are perpendicular. Okay? And number 3, if measure of angle 1 equals 90 degrees, then line WY must be perpendicular to line ZX. What allows me to say that? Well, again, that's definition of perpendicular lines. All right, let's look at a second example. Okay, in this example, we have this diagram. So this is A, B, C, D. And then we have angle 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so name the definition or theorem that allows us to make the following statements. So number 1, if segment AB is perpendicular to segment BC, then angle ABC is a right angle. Okay, so segment AB is perpendicular to segment BC, then angle ABC is a right angle. And the thing that allows me to say that is definition of perpendicular lines. Number 2, if segment BD is perpendicular to segment AC, then angle 3 must be congruent to angle 4. Okay, what allows me to say that? If two lines are perpendicular, then they form congruent adjacent angles. Okay, number 3. If segment DC is perpendicular to segment DA, then angle 7 and angle 8 are complementary. Okay? Right? And the thing that allows me to say that is the theorem that says if exterior sides of two adjacent acute angles are perpendicular, then the angles are complementary. Okay? Okay, number 4. If angle 7 and angle 8 are complementary, then measure of angle 7 plus measure of angle 8 must equal 90 degrees. What allows us to say that? Well, that's definition of complementary angles. Number 5. Measure of angle 4, angle 4 is congruent to angle 5. And we can say that because of vertical angles are congruent, the vertical angle theorem. Okay. All right. Let's move on to a proof. Well, actually, let's move on to a third example here. Okay. If ray ZW is perpendicular to ray ZY, and measure of angle 1 equals 5x, and measure of angle 2 equals 2x minus 1. Find value of x. And here's the picture. Here's W, here's Z, here's Y, and here's V. Okay, and this is angle 1 and angle 2. All right? Well, since ZW is perpendicular to ZY, those are exterior sides of angle 1 and angle 2. And so by the theorem we know that they must be complementary. So then we know that measure of angle 1 plus measure of angle 2 must be equal to 90 degrees. So then we can say 5x plus 2x minus 1 has to equal to 90 degrees. So now, just using our algebra, so x must equal 13. Okay, so that was just by applying the theorem. Okay, and finally, let's do this proof. Given that segment BA is perpendicular to segment AC, and angle 1 is complementary to angle 3. Prove that measure of angle 2 equals measure of angle 3. And our picture this is A, this is C, D, B, and this is angle 1, 2, and 3. Okay, so here are our statements and our reasons. Alright, so first of all, we're going to say, number 1, that segment BA is perpendicular to segment AC, because that is given, right? And we're just going to use that part of the given for right now. So what does that tell us about the picture? Okay, so if this is perpendicular to this, what do we automatically know about the picture? Well, we know something about angle 1 and angle 2. What do we know about those two angles? We know angle 1 and angle 2 are complementary. Okay, and that's because if exterior sides of two adjacent acute angles are perpendicular, then the angles are complementary. That's how we knew that. Okay. We also know from the given that angle 1 is complementary to angle 3. That's given. Okay. Well, what do we know about complementary angles? What can we say that's true about complementary angles? Well, we can say measure of angle 1 plus measure of angle 2 has to equal 90 degrees. And measure of angle 1 plus measure of angle 3 also has to equal 90 degrees. Okay? And we know that by definition of complementary angles. Okay? Now, notice that what we want is for measure of angle 2 and measure of angle 3 to be across from each other. And notice that in line 4, that both of these equal 90 degrees. And so in place of this 90 degrees, I can write this. So by substitution, I can say measure of angle 1 plus measure of angle 2 has to equal measure of angle 1 plus measure of angle 3. And that is by substitution. Okay, now I've succeeded in getting measure of angle 2 across from measure of angle 3. But I want them to be by themselves. So I need to get rid of this and this, which means I want to be able to subtract that. But do I know for sure that those are equal to each other? Okay, well, I have to state that. Measure of angle 1 equals measure of angle 2. I'm sorry, measure of angle 1. What property allows me to say that something is equal to itself? That is the reflexive property. Okay? And now I can take that and subtract this from this side and this from this side. And that leaves me measure of angle 2 equals measure of angle 3 by the subtraction property. Okay, and we're done.